Right now, somewhere in a forest you will never visit, an animal is watching you. Not you specifically, but a human. And the moment that human turns their head and the animal sees the whites of their eyes, something ancient fires inside it. It goes completely still. It does not run, it does not hide, it does not make a sound, it freezes and it waits. That response is not random. It is not learned. It is written into the nervous system of almost every wild animal on the planet at a level deeper than thought. And the story of why it got there is one of the strangest things evolution has ever produced. Let's start with something you probably already know but have never thought about carefully. Most animals do not have eyes like yours. A rabbit's eyes sit on the sides of its skull, giving it nearly 360 degrees of vision. A goat's pupils are horizontal rectangles. A gecko's pupils are vertical slits. A tuna has eyes that move independently and can see almost everything except what is directly behind it. These are prey animal eyes. They are built for one thing: detecting movement anywhere in the environment so the animal knows when something is coming for it. Predator eyes are completely different. Wolves, eagles, owls, humans, all of them have forward-facing eyes with overlapping fields of vision. That overlap is what creates depth perception. And depth perception exists for one reason: to accurately judge the distance to something you are about to catch. Forward-facing eyes are not a design for living in the world. They are a design for targeting something inside it. Every prey animal on Earth has spent millions of years learning to read that difference, not as knowledge, as reflex. When a rabbit sees a pair of forward-facing eyes lock onto it, its nervous system does not wait for its brain to decide what to do. The amygdala fires before conscious thought even begins. Muscles freeze, breathing slows. The animal becomes as invisible as it can possibly make itself. That response evolved because movement kills prey animals. A rabbit that bolts at the first sign of a predator is a rabbit that gets chased. A rabbit that freezes makes itself harder to see, harder to track, harder to follow. The freeze buys time. It buys information. It lets the animal assess whether the predator has actually seen it or is just looking in its general direction. And here is the part that changes how you think about this. The freeze response does not require the animal to actually be seen. Researchers studying deer behavior found that deer freeze when they detect forward-facing eyes, even when those eyes are not looking directly at them, even when there is no associated body, no smell, no sound, just the shape of two eyes, side by side, facing forward. They ran the experiment with photographs, still images. Forward-facing eyes on a flat piece of paper triggered measurable freeze responses in deer that were not in any danger at all. The stimulus is not the predator. The stimulus is the eye shape itself. This is what biologists call an innate releasing mechanism, a preloaded trigger built into the nervous system that fires automatically in response to a specific pattern. No learning required. No experience required. You see the shape, you freeze. And that shape, two forward-facing circles with a dark center, is one of the most ancient threat signals in the animal kingdom. There is fossil evidence suggesting this response existed in prey animals more than 50 million years ago, before modern mammals, before modern predators. The architecture of the freeze was already there. What humans did to it is something else entirely. For most of the history of life on this planet, forward-facing eyes meant one of a small number of things: a cat, a bird of prey, a wolf, a snake in some cases. Dangerous, certainly, but bounded, predictable. If a wolf found you, the outcome followed a pattern that evolution had already built a response for. Humans broke the pattern. We do not hunt like other predators. We do not stalk and sprint. We do not wait and ambush and lunge. We follow, we track, we disappear and come back days later. We kill from distances that should make killing impossible. The landscape of fear that humans created is not built around teeth or claws. It is built around our eyes. Because when a wild animal looks into a human eye, it is not just seeing a predator. It is seeing something that has been learning about it, watching it, planning around it. Something that is killed from a distance, that never has to get close, that can follow a trail invisible to every other hunter on Earth. The study conducted in Mozambique played audio recordings of lions, leopards, hunting dogs, and humans to wildlife near watering holes, and measured how quickly animals fled and how far they went. The animals fled humans faster than lions, farther than leopards. The sound of a human voice triggered a stronger fear response than any other predator on the planet, including the ones with teeth. But here is what makes the eye response specifically so powerful. When an animal hears a lion, it knows where the lion is. When it smells a wolf, it knows roughly what direction the wolf is coming from. Sound and smell give location. Eye contact gives intention. The moment a predator's eyes find yours, you know it has seen you. The ambiguity is gone. Whatever was going to happen next starts now. For prey animals, eye contact is the starting gun. And because humans established ourselves at the top of the fear hierarchy across every continent over hundreds of thousands of years, human eye contact carries more weight than any other species. Researchers working with wild chimpanzees in Uganda documented something that took years to fully understand. When a researcher entered the territory, the chimps would watch from a distance. They would track the humans' movements. They would position themselves in trees above the path. But when the researcher made direct eye contact with a chimp, the behavior changed instantly. The chimp looked away, or it retreated, or in dominant males, it held the gaze for exactly as long as it calculated it could before breaking it. What the researchers realized was that the chimps were not responding to a threat, they were responding to an acknowledgement of mutual awareness. Eye contact to an animal is not just about danger, it is about information. It means the other creature knows you are there, and an animal that knows you are there has to make a decision. The freeze is that decision in its earliest form. A pause to calculate, to read the predator's posture, its direction, its speed, its intent. All of that information comes through the eyes first. Which is why the response to eye contact and the response to being hunted are built from the same hardware. There is one more layer to this that almost nobody talks about. Humans evolved in a world where making prolonged eye contact with an apex predator was almost always a terminal experience. Our own deep wiring around eye contact is not so different from a deer's. We hold a stranger's gaze just long enough to signal that we are not a threat. We look away in crowds to avoid triggering confrontation. We feel physically uncomfortable when someone stares at us without blinking. That discomfort is not social anxiety. It is the same ancient circuitry, the same reed of forward-facing eyes locking on to you. The freeze lives in us too. We just call it something else. So the next time you are in the woods and you look up and something is looking back, and it goes perfectly still the moment your eyes meet, you are not witnessing an animal being afraid. You are watching 50 million years of evolutionary memory fire in real time. It is not afraid of you specifically. It is afraid of what you mean, what you have always meant. What every pair of forward-facing eyes in the history of this planet has meant to the things that run from them. That you see it. And that seeing is where the danger starts. If that question has been living in the back of your head your whole life, there is a lot more where that came from.